Okay, for problem 2, we're looking at these light bulbs here, and we're comparing to 760. Reading through here, we have a level of significance of 0.01, and we have a sample size of 16, and a sample mean of 778, and it says we have a population standard deviation of 91. That means that we're going to be using the z-table for these, and we're going to, and no degrees of freedom or for that. And if we were using looking for a critical value, we'd remember to just go to the bottom row of the t-table. In this case, we're actually going to use the z-table. But for critical values, you would just go to the bottom row of the t-table without correcting for degrees of freedom. Okay, so then it says, can we conclude that the population mean is greater than 760? Put that in the alternative, depending on what book you're using. That's HA, H1, sometimes HR, and HO will always be the equality. And so the first thing, that's part A. When we get to part B, we're going to conduct the hypothesis test using the p-value approach. And it says show all work. It also says let alpha equal 0.05. Stick with the 0.01, which we had above. It I guess doesn't make that much difference, but that's what I'm going to do when I work it. But we're going to have to compute the p-value by hand here. So in order to do that, we'll have to compute the z-test. So I guess the first thing we'll do here is for the p-value test, we're going to reject HO if the p-value is less than whatever our level of significance was. Looks like I said 0.05 in one part of the problem and 0.01 in the other, but it really doesn't make any difference which one you put there. We're going to need now to compute the p-value. To do that, we'll have to compute the z-test first. And I think I'll do that on a different screen here. So z-test is equal to x bar minus the mean that we have hypothesized divided by sigma divided by the square root of n, or sigma x bar. 778 minus 760 divided by 91 divided by the square root of 16. And that all comes out to be 0.79. So that means we're 0.79 standard deviations or standard errors above the mean, above the hypothesized mean. And that gives you an area of 0.2852. And let's see here, I think I'll do this on this page. We draw our curve out here. It's an x bar. Our hypothesized mean was 760. We're out at 778. It's really a little bit further over here, but I'll leave it like this. And this area is 2852. So the p-value is going to be out here, or 0.5 minus 0.2852 will give us 0.2148. And that's the p-value. So now we'll go back here to the previous slide. And we have a p-value is equal to 0.2148. And that is not less than 0.01 or 0.05 if that's the one you used. And so we will fail to reject HO. And so we will conclude that there's insufficient evidence to conclude that that the population mean is greater than 760. And in this case, that leads to the decision of just keep the light bulbs that you have. We're not going to change to our manufacturer's competitor unless they can show us that they really do have a population mean greater than 760. Okay, so part C asks for a a fuller interpretation of the p-value. And so for that, let's just go back to the distribution that we have here. And basically what Part C asks is for you to put this in the form of a conditional statement. And I'm really basically just reading this graph. If mu is equal to 760, if the null hypothesis is true, then there is a p-value chance, a 2148 chance, that a sample mean greater than or equal to 778, that's this stuff, greater than or equal to 778, will be observed or obtained, or however you want to put it. Okay, so make sure on the p-values that you have that conditional kind of notion there. If HO is true, then there's a p-value chance of getting a sample mean greater than or equal to that particular point. Okay, to use the calculator for number 2, we're going to do a z-test. So we'll do stat test z-test, and this is just a z-test for the mean. Our null hypothesis was that we are equal to 760. Our population standard deviation was 91. Enter the standard deviation, not the standard error. We had 778 for the sample mean, and our sample size was 16. And our alternative hypothesis was greater than, and then just calculate. And you can see that we have a z of 0.79, that matches up, and a p of 2144, which is pretty close to the 2148 that we had there. You can actually, this is not necessarily necessary, but you could also do stat, test, z-test, and when you get down to the bottom here, you can select draw, and there's the what your curve should look like.